almost everything at a basic level. Okay, so we are going to run this to see how it works, and then we are going to go in a second round with a little bit more of detail. Okay, so to run this test, I'm going to do the following that I usually do. Let me go to the platform. I'm going to, this is not needed, but just for me and you to know that this is really producing the data. I'm going to my data storage and delete algorithmic trading folder. So all the backtests and stuff that I have run before are gone. And that means that now I'm going to come here. And for running this, you need to run also the peer-to-peer network itself, okay? So I will need to teach you a little bit about the peer-to-peer network, it seems. Okay, I will do that later. First, I want to show you how it works. I have the peer-to-peer network running in this Visual Studio Code. I know that it's running because all this is good, okay? So I will follow up that explanation after we see how this works, okay? So how to test this? It's very simple. You just run all the tasks, and the task that is sending the signals is going to run, and the one that is receiving the signals is going to run too. Okay, it takes a while, but it does. My machine is like not so fast lately. Okay, so it's running. Okay, it's running. So then the next thing to do is we're going to use this session to listen to the signals. So this is going to start running, but it's going to get stuck. This is the lightning strike strategy that everybody knows, running on September 1, 2020. Okay, and then I'm going to run the session for sending the signals. So here we go. You will see here that is going through all the candles of the day. Okay, and there's almost no delay for the normal speed because the signals are sent in this moment. So here is going to GitHub, saving this file or encrypting, saving, and then sending the key over the peer-to-peer network. Okay, and it's done. So this guy received the signals over the peer-to-peer network. The file key went to GitHub, got the file, decrypted, and start processing all the signals. Okay, and there it finished. If we had more than one day, this would continue processing the second day, then the third day, then the fourth day, and each time would be doing the same process. Okay, we don't need to test that now. And at each day, it would send a signal and it will start processing this. So it will be like one day behind all the time. So we can stop this now. We can stop it, and if we check the charts, we have that the bot sending the signal has the chart that we already know for this back test. Okay, and the guy who was receiving the signals has exactly the same chart. Okay, it's one day with some activity at the beginning and some activity in red at the end. So exactly the same because it did exactly the same, but without reading the three indicators that the other guy was reading, that was candles and resistance and support, and probably I don't know what else. But the other guy, this guy is only reading the candles in order to produce its own simulation, and all the other stuff is produced with information that came through signals. That means that the value of the formulas for where to put all these orders and when to activate each of these orders, and absolutely everything came inside each of the individual signals that were packaged and sent via the peer-to-peer network. Okay, so this proves that we can send and replicate a strategy in detail with a very high granularity, okay, across the internet over a peer-to-peer network. Okay, it's working. So the next thing I want to show you is this detail of how the information is stored so that you have a better idea of this. So if you check my user or your user once you have it running in GitHub, I have this repository, my trading signals. Okay, so this is a little bit messy here because I have some tests, but the structure of this is here, 2020, 22, January, today is 24, okay? And these are all my tests of today. Now it's 17 hours, 5 minutes, okay? And these are the two files, one from 1st of September, the other 2nd of September that is almost empty because it detects that it has to stop there, okay? So the 1st of September is a file that I will open the file, okay? Okay, so this is not the first file, this is the second, but it's in the wrong order. Okay, so this is 1 day worth of signals at 1 minute with lightning strike, sending signals of absolutely everything is 6 megabyte. So this is what we are avoiding sending through the network. It's just being sent, recorded here, and we send this location and the way to encrypt this data. And if you want to see the data, well, good luck with that because it's encrypted, okay? You cannot see it, as well as nobody can see it, or just like that, okay? Beautifully encrypted. Not even GitHub can know what you have here, okay? So these are all the signals that produce that backtest, essentially. So if you add to this encryption, you add the fact that the name of the repository, you might put some random string of number and letters, then you have GitHub wondering what is actually going on there because it doesn't know that comes from Superalgos, because it doesn't even need to be at your profile. You can have a second profile for storing information that is not your actual profile, okay? And the name of the repository, you put just one random string of number, and then these kind of things are going to be recorded there. Nobody can know where they are coming from or what is going on there, and nobody can even suspect that these are signals from the Superalgos trading system. So even though the password is going through the network through to all the bots that are following your bot, but from the point of view of the storage provider, that can be GitHub, Amazon, or whoever, they don't really have any clue, so they have no arguments of why they should delete your stuff. So probably they won't do it. Okay, so that was something I wanted to clarify. Okay, so this is how this works. This is the very basic explanation. There is a deeper explanation that doesn't go that much deep,